Hello and welcome to TidyX episode 169. TidyX's screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking in at TidyX episode 169. We just finished talking about plotting and things like that, and now we're moving on.
Yes.
We're gonna do, I think, what did you call it? You called this like R in 20 minutes.
Yeah, we're aiming in 20 minutes for you to know how to go through a basic data cleaning, processing, and analysis in 20 minutes. Let's see if we can hit it.
And I think the only thing that we left off is probably data visualization, which we should have had. But we will be better for it next time.
Yes.
We're going to talk through this. The goal here, like Ellis said, is we're going end to end. You got a research question, procure some data, engineer a data set, build an analysis, and you're out the door in 20 minutes. Here we go. Start the clock.
All right, let's do this. All right, so what we're going to be doing today is trying to predict the next Hall of Fame class of 2024. We've not gotten there yet. I think some of the voting has started, but what we wanted to do is, can we predict from stats alone who is going to be in this next class? So what we're going to do is we're going to load Lawman for all the data that we're going to need to analyze to predict this, as well as using the library tidyverse to load all our data manipulation packages like dplyr and whatnot for us to use. So let's load that. Next thing we're going to do is we need to generate our data sets. And so arbitrarily, I am drawing a line saying I don't want to include anybody in this data set that started their rookie year before 1970. And this is arbitrary, but this is just assuming that players pre-1970 were probably very different. I think there's been a number of rule changes. So let's lop those people out of the data set. That could make this a little bit more muddy. So what I'm going to do is I'm going to take the batting data set from the Lawman package. I'm going to filter to keep all the years prior to 1970, pull the player ID and get the unique of that. So these are all the players that played pre-1970. And then I'm just going to take the batting data set and I'm going to filter to keep all the cases where that player ID doesn't exist. So they may have continued to play past 1970, but I'm going to be removing them. So only rookies or people that started playing baseball professionally after 1970 are going to be included in this data set going forward. Then I'm also going to remove the pitchers because they don't tend to have great batting statistics, and we're looking just kind of at batting stats in this situation here. So we're going to, again, take batters post 1970, filter them to keep all the player IDs that are not in the pitching data set, and remove those guys. So now we end up with how many of that? 26,000, nearly 27,000 batters from 1970 on. But now we need to filter to remove all the players that are ineligible for the Hall of Fame. Patrick, do you want to take us through this one?
Yeah, so there's an eligibility criteria to make it to Hall of Fame. You have to retire, then you have to basically sit retired for 5 years before you can get to the Hall. And then you have a 10-year window where you can be voted in. So frequently you'll see a guy not make it on his first ballot unless it's a real superstar, but maybe make it on the third or fourth or fifth or sixth ballot as they accrue votes and accrue popularity. And then the writers or the voters finally feel like they're ready to put them in.
Petition them like, hey, let me in.
Yeah, exactly. So we're going to take our batters post 1970, and now we're doing a little bit of filter here. So first deal is we're getting everybody with their max year in the data set, less than 2019. The one quick note I'll say here is because Ellis has a newer version of tidyverse, he didn't have to put a group by in at the top. He actually wrote the .by directly into the filter. So depending on the version of tidyverse that you're using, you might have to switch the code around just a little bit, but that's the fix for it. Okay, so we're filtering by all the players that did not play in 2019 or higher, because those are the guys that we want to try and investigate further for Hall of Fame potential, induction. Future years. We need to get a little bit of a measure that says whether or not they were 10 seasons post retirement. So their max year minus their min year is going to be anyone that is over 10 years, right?
So this
Post 10.
is this is in order to get voted into the Hall of Fame, they need to have played for at least 10 years.
Oh, sorry, this wasn't the
Yeah.
filter. Yes,
Yes.
that's right. Sorry, played for at least 10 years. That's min year minus max year needs to be greater or equal to 9. And then the sum of the at-bats, just we're going to throw out anybody that didn't, that didn't have more than one at-bat, just because chances are nobody's talking about you for the Hall of Fame anyway, if that's the case, right?
Sorry everybody that did not bat at least once, but I don't think
Yeah,
you're going to get into the Hall of Fame unless you're getting in for other reasons which we're not looking at in this situation here.
like pitchers.
Yeah.
And then generating some career statistics. So we're going to take that eligibility data set, we're grouping by the player and the year ID, and we're summing across all of the relevant kind of game hitting stats. And so remember, summing across is saying across all of those rows, we're going to do the sum of each of those rows for every player for every year. So effectively, we have a player years table right now, which we're going to then further collapse down by grouping by just the player ID. So we're going from a player years table, and we're collapsing that down into a player's career table. So by player ID, we're going to first identify the best batting average year that they had, their best batting average, max of hit and AB, best season that they had, their career batting average, so the sum of all their hits and at-bats, their best scoring season, which is the max of the runs that they created, and then going across all of the other stats, we're just going to sum those up, and those are now going to be at the player career mark. And then the final season is basically the max number of years that the player has within the data set. So the max year ID is that final season year for them. So now we have a cool data set that has everything grouped on the player career level.
Yes, indeed.
Yep. And now we are ready to pull in some Hall of Fame metadata from the Hall of Fame table. Ellis, what do you got?
All right, let's do this. So the Hall of Fame data set is pretty cool. It's got a bunch of metadata in it. So let's take a quick head of Hall of Fame. So we've got the player, the year that they were voted in or voted on, who voted for them, the number of ballots, the number that they needed, the number of votes that they got, whether they were inducted or not, and then some other metadata about it. But for our case and for our analysis, all we care about is the player and were they inducted, yes or no. So we're going to select only the columns player ID and inducted. The difficulty with this is, again, a player can go up multiple years. If they don't get in their first year, they could go up and be voted for in their second year, their third year, fourth year of eligibility. And what we're caring about is this player a Hall of Fame player? End of sentence. Therefore, what we're going to need to do is group by player ID and summarize to basically try to collapse to get down to that core, were they voted into the Hall of Fame, yes or no? So we're going to group by player ID, summarize, and say, is there a yes in their inducted column? If yes, great, we're going to set inducted to true, because the sum of inducted yes is greater than 0. If they were never inducted in because they went up 10 times and they were voted down every single time, or they went up 3 times and they voted up to the point of this data set, if they've not been inducted, it's going to be false. So we run that. So we end up with HOF. So this player was inducted. This player was not inducted. This player was not inducted. There's a lot more players that are never inducted than players that are, because it's the Hall of Fame. You don't get to be in the Hall of Fame. Everybody doesn't get to be in the Hall of Fame, unfortunately. So now we're going to combine the career stats information that we have from all players post 1970 with the Hall of Fame dataset using a left join. And so that's going to take our career stats and plop on the Hall of Fame to it. So even if there are extra players in the Hall of Fame dataset that aren't in our career stats, because we're left joining it, those will just go away. On top of that, by left joining, we are going to be keeping all the records within our career stats, even if they've never been voted for in the Hall of Fame. So that's why we did a left join. And we're doing this by player ID, which Lawman does a wonderful job of making sure that key is basically in every single table that exists. So it's very nice to be joining them all together. So now we have this batters post 1970 that are eligible, career stats, and we have their Hall of Fame metadata included in there. So this is quite a long object name, but it is very descriptive, which is how you should set up your name your variables as well, even if they are very long.
Mm-hmm.
So now we have the data sets that we're going to be performing analysis on, and data sets. So basically, we have all the data that we're going to need for analysis and prediction going forward. So in what was that? 8 minutes?
8 minutes.
Our data is ready for analysis. Isn't that amazing? If you like that, like below. All right. Gotta plug that because that tells the algorithms that we're doing a good job here. So now what we're going to do is we're going to be pulling out the newly eligible players because they're not going to have been voted for yet in this data set for the Hall of Fame. We want to predict who out of the newly eligible players will be or could be inducted based on their statistics. And so we're going to take this metadata and we're going to filter for all final season is 2018. So we end up with a data set that is 21 players long. So there's not a ton of players apparently in our data set that are eligible starting this year.
Mm-hmm.
Now we have to do a little bit more complicated parsing to get out who are players that we know they're definitive, they're going to be in Hall of Fame or not, or who are the players that are still to be determined, that we don't know whether they're going to be officially or not inducted for whatever reason. So we're going to take this batters post 1970 eligible career stats Hall of Fame. We're going to filter to keep all players whose final season is less than 2018. So those are all people that in theory been voted for in the past or have been eligible to be voted for in the past since 1970. We're going to then mutate this to say, okay, if the cases where they have some sort of information about whether they've been inducted or not, we're going to keep that. But then we're going to add in this other piece of information, which is if they were never voted for, but their last season was greater than 2009, which is more than 15 years ago, which is the total length of time that somebody could have been voted for, we're going to set that to be false because now they are out of eligibility to be voted for into the Hall of Fame. So we're going to just set that to be false because they weren't inducted. It's a little bit confusing, but hopefully that's clear to you all. So now we're going to filter that and we're going to generate this eligible career stats Hall of Fame sans 2018 all. We're now going to take this and split it down even further. So because there's some people that we don't know what their final status is yet necessarily, because they may have been voted for and they were voted no, but they still have eligibility. They still could go up this year, next year, the year after that, and be voted and inducted into the Hall of Fame. Mm-hmm. So we're going to generate this final data set, which is they weren't voted. So we're going to take the Hall of Fame sans 2018 all. We're going to remove any cases where inducted is still NA. And then we're also going to filter to keep any records where the final season is less than 2009. Again, these are people that we have the final resolution for them. We know that they cannot be inducted or that their Hall of Fame status cannot change. So that is their final status. But then we're going to do this other set, which are the TBD people, the people that we're still waiting because they still have eligibility even if they haven't gotten in yet, or they don't have any votes for them or not. So we're going to take this again, 2018 all. We are going to say if their inducted value is false or it's NA, and their final season is still greater than 2009, so they still have potential votes, or opportunities to be voted for, we're going to throw that in the TBD column, or the TBD data set. So now we have three types of data set. We have the final data set, which tells us, okay, here's all the records and the patterns of voting for the writers that vote people into the Hall of Fame. We have the people that we're not sure what their final status is, but they've technically been eligible for a number of years. And then the last one is the new 2018 class, or the new people that are eligible as of this year. So now we're going to fit a model. Patrick, do you want to show us how we do that?
Okay, so we're going to be using a generalized linear regression, a logistic regression here. Why? Because the outcome variable, if you remember, is binary. So it's either true or false. You either made it into the hall, yes, or you did not, no, over the tenure of time that you were able to be voted in. So we're going to fit this, this fully loaded model. We use the GLM function because it's a generalized linear model instead of using LM. All the syntax around the model is the same as linear models. So we have an outcome variable or a dependent variable on the left side of the tilde. And then we're trying to estimate that outcome variable by a whole bunch of predictor variables or independent variables. In this case, it's all the potential offensive batting stats that a player can have. We have to use this family equals binomial. And we're basically saying binomial distribution is basically the 0 or the 1. It's the yes or no outcome. It's a binary outcome. And the link is logit. So basically, we're going to use this inverse logit link to take this generalized linear model and be able to turn it into a linear model so that it makes a little bit of sense for us, right? The data that we're going to use is this final data.
I have not been running this, which is my bad. There we go.
There you go. All right. So now we've got a model that we have run. And when we hit summaries, we're going to see all of our coefficients. We used a whole bunch of variables. The model really kind of seems weird. It doesn't make a lot of sense. Many of these variables are highly correlated with each other, so they probably, cancel each other out or do, behave weirdly in the model. And also the coefficient for runs and hits is negative, which if you told someone like a coach that having more runs and hits decreases your chance of making it to the Hall of Fame, they'd probably look at you like you're crazy. So this loaded model, there's different ways of dealing with this and selecting predictors. We could certainly talk about that in future episodes. You could like and subscribe, drop comments down below.
Let us know.
We're going to use this smaller model. So we're going to basically base the outcome inducted, yes or no, on best batting average, the career batting average, and the runs scored. Again, family is the link, logit, binomial link. And we get this smaller model, and this makes a little bit more sense. We have the coefficient estimates for each of those variables. These are on a log odds scale, so they're kind of hard to make sense of. We can look at these coefficients on a normal odds scale by exponentiating them. So if we ran the coefficients, so exponentiate and coef. There we go. And so now we can look at these on so for example, best batting average. For every 1 unit increase in best batting average, we would see a 17.6 times greater chance of making it to the Hall of Fame. That's on a relative scale. So this isn't this isn't exactly like an absolute change. It's not like they go up 17 times or something like that. Yeah. So that's on a relative scale. One of the easier ways to explore logistic regression is to, or really any model, is to understand its behavior by inspecting what happens when you change a variable, what happens to the outcome. So in this case, we'll create a new player who is representative of the average value for each of the independent variables in our model. So we just pass the mean of those values, and we have this new player, and then we have a second new player. And we're going to hold the batting average, the best batting average, and the runs constant. So they're going to look like that new player above. The only difference is we're going to add 0.05 to the mean of the career batting average. Okay.
So you can
Now
see
we have a,
that's now
yep,
0.3, and that was 0.259.
correct. And then we predict, and when we predict with this binomial model, we're going to put in type equals response, and that's going to convert the prediction back to a probability for us. So it's bounded between 0 and 1. So if we run the first one, that new player has about a 0.06% chance of making the Hall, conditional on being average in all of the three main categories. Now, if they're average in best batting average and runs, however, they're a 300 hitter, we're going to estimate, or the model would estimate, that there's about a 0.9% or really a 1% chance that this player is a Hall of Famer.
Hmm.
So this is a way you could create little simulated data sets to kind of explore how your model behaves in different circumstances, but this is one way to investigate the model. So now if we apply these predictions to the full data set, we can get a look really to finish this out, we can get a look at who has the highest probability of being voted into the Hall based on our eligible players.
Yeah, it's cool. Let's do this. So y'all may remember this Batters Eligible Career Stats Hall of Fame 2018. These are the new set of people that are available as of this year to be voted into the Hall of Fame. So we're going to take this trained GLM select, as we did earlier. You may have just seen me update it. That was because we were looking at some other stuff before recording this. So we're going to be predicting on the 2018 folks. Let's see if we say 0.1%. So say they have a 10% chance of getting in. How many people would get in potentially? Three. Three out of the 21 folks that could get in. So let's take a quick peek at that. So let's, copy paste that in. I'm going to take the eligible folks. I'm going to add in the predicted or the likelihood of them getting in. I'm going to filter to keep all cases where the prediction is greater than 0.1. I'm going to left join in with people, which has a bunch of additional information about this person, such as their name. And then I'm going to select to keep the first name, the last name, what was the prediction that we had them getting in, and then some of the stats that we looked at. So if we run that, so Adrian Beltre has a prediction of 0.599. So we're fairly confident there's a high probability of this individual making it into the Hall of Fame based on their statistics. Again, Matt Holliday and Joe Mauer. I've looked up Adrian, and according to the pundits that I've read very quickly, this individual does have a high likelihood of getting in on their first ballot. So our prediction worked. But that's not the only set of people. There are the other folks that are still TBD. Out of the people that have not gotten in yet, what is their likelihood of getting in? So we can run this on the TBD data set. And this time I'm going to just leave it as a 0.5 prediction. And we're saying 6 of these 223 folks that are still technically eligible are going to get it. So who are they? So let's take this data set here. Again, we're going to mutate and add in the predictions that we have for them. We're going to filter to keep all cases greater than 0.5. We're going to left join in people, select, and then select the first and last name, prediction, best batting average, career batting average, etc. And then arrange by descending prediction. So the highest prediction starts at the top and it goes down. And this is just for us to visualize it because there isn't much in that. And so, based on statistics, one of the last people that is the highest probability per our model to get in is Alex Rodriguez, which I think, based on his stats, does have a high likelihood of getting in. However, Hall of Fame I don't think is just based off of stats. And so that's where some of these models might break down a little bit, is because there's outside effects that may happen in your models, or things that happen outside of your models that you can't actually handle in this. But it's good that it's calling out some of these high stats players, Manny Ramirez, Todd Helton, Johnny Damon, that have a potentially high likelihood of getting into the Hall of Fame, but for other reasons may or may not get in. And so with that, I think we did successfully. If you
We're
give
at
us a little bit
24.
of flub around or fluff around talking through some of these things, achieve an analysis in 20 minutes or just over 20 minutes if you'll give it to us. Hey, if you liked this, though, leave a comment down below if you'd like us to do more of these very quick hitting videos on how to quickly go through the process of analysis in 20 or 30 minutes. Patrick, do you have anything to add?
No, there's a lot more we could talk about with respect to this stuff in terms of model fitting workflow. There's years post-career that a player could get in where they're voted for. This could be like, you could think of this as a survival model. So what's the probability of making it in given years, and how does that change conditional on information that we might pull in? There's other ways of checking how how calibrated this model is, what its discrimination is. We could talk about bootstrapping the predictions. There's lots of other ways we can take this in terms of model fitting. If that's other stuff you'd like to see, you could like and subscribe. Let us know in the comment section. Other than that, I think that's episode 169.
All right, yeah, I think it is. Thank you
Yeah.
all for joining us for another episode of TidyX. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And you can find me on Twitter at @OSPPatrick, @tidy_explained is where the screencast lives on Twitter. Of course, easiest way to get to us is YouTube channel, like, subscribe, drop comments down below. And if you enjoy the show and would like to support it, we appreciate that. We do have a Patreon page. We're grateful for anything that you'd like to donate.
Thank you so much, and keep on exploring your world.